2,000 years before the Industrial Revolution, a Greek engineer built a working steam engine. It spun. It generated power. And then humanity forgot about it for 17 centuries. How did ancient Greeks master steam power so early? And why did they never use it? The year is 62 AD. In the legendary city of Alexandria, a brilliant engineer named Heron demonstrates something that should not exist for another 17 centuries. A metal sphere suspended between two supports. Water heated beneath it. And as steam escapes through two bent tubes, the sphere begins to spin. Faster and faster. Pure rotational energy, generated by steam. Heron called it the Aeolipile, named after Aeolus, god of the winds. And here is what makes this genuinely remarkable. This was not a lucky accident. This was not primitive tinkering. When modern engineers analyzed Heron's original designs, they found sophisticated understanding of thermodynamics, pressure differentials, and rotational mechanics. Knowledge that supposedly did not exist until the 1700s. So our central mystery becomes this: if Heron understood steam power well enough to build a working turbine, why did ancient civilization never harness this technology? The answer involves economics, slavery, and a twist that will surprise you. But here is where it gets interesting. The Aeolipile was not Heron's only invention. And understanding his other creations reveals that this was no isolated curiosity. Heron designed the first vending machine. Insert a coin, receive holy water. He created automatic doors for temples that opened when priests lit fires on altars. The heated air expanded, pushing water that pulled ropes that swung the doors wide. He invented a wind-powered organ and a programmable cart that followed preset paths using falling weights and strings. This was systematic engineering. Each invention built upon principles Heron clearly understood at a theoretical level. If you are finding this fascinating, that like button tells me to keep investigating these mysteries. The ancient Greeks had something we often overlook: the Antikythera mechanism, discovered in a shipwreck, contained over 30 bronze gears calculating astronomical positions with clockwork precision. These were not primitive people stumbling onto discoveries. They possessed genuine mechanical genius. So the question becomes even more puzzling. With all this knowledge, all this capability, why did they not take the obvious next step? Let me take you inside the mind of an ancient Roman economist. And what you discover might disturb you. The Roman Empire ran on slavery. At its height, an estimated 25 to 40% of Italy's population consisted of enslaved people. They mined ore, worked farms, built roads, and powered every industry. Here is the dark math. Why invest in expensive, complicated machinery when human labor costs nothing beyond basic subsistence? When a slave died, you simply purchased another. There was zero economic incentive to develop labor-saving technology. But wait. Let me put this in perspective. Imagine you are a Roman factory owner. Someone shows you the Aeolipile and suggests scaling it up to power mills. Your response: why? I already have 50 slaves working those mills for the cost of bread and water. Technology that replaces labor only becomes valuable when labor becomes expensive. The Romans never faced a labor shortage severe enough to make Heron's invention economically attractive. The steam engine was not forgotten because it failed. It was forgotten because it succeeded at something nobody needed. But here is what nobody expected. Modern engineers decided to test whether the Aeolipile could actually have powered ancient machinery. In 2014, a team built an authentic replica using only materials available in ancient Alexandria. Bronze casting, clay seals, charcoal fuel. No modern alloys or precision tools. The results shocked them. Their Aeolipile generated enough rotational force to turn a small grinding wheel. Not efficiently. Certainly not by modern standards, but it worked. The engineering was sound. The principles were correct. What the Greeks lacked was not knowledge but material science. Ancient bronze could not withstand the pressures needed for larger boilers. clay seals leaked at higher temperatures. But here is the revelation that changed everything. A research team in Germany analyzed Roman concrete and discovered it contained volcanic ash that actually strengthens underwater over centuries. The Romans had materials expertise we are still studying. If they had applied that same ingenuity to metallurgy, to developing pressure-resistant alloys, the steam age could have begun in the reign of Emperor Trajan instead of under Queen Victoria. But that is not even the most remarkable part. Because Heron's steam engine had a secret that historians missed for centuries. And discovering it changes everything. In 2019, a classic scholar re-examined Heron's original Greek manuscripts. What she found buried in his technical description stunned the academic community. Heron did not present the Yalopile as a toy. He presented it as a demonstration of principles that could be scaled. He explicitly discussed using steam pressure to lift weights, to move objects, to do what we now call work. Think about what this means. Heron understood that steam could replace human effort 1700 years before James Watt. He wrote it down. He published it in treatises that circulated throughout the ancient world. This was not lost knowledge rediscovered. This was knowledge deliberately not pursued. If you want to see how this mystery resolves, make sure you are subscribed. Because what comes next explains why humanity chose not to have an industrial revolution when it absolutely could have. And the reason has implications that extend far beyond ancient history. Here is where we need to talk about something uncomfortable. The ancient world had a philosophy problem. And I need you to pay attention, because this explains one of history's greatest missed opportunities. Greek and Roman thinkers divided the world into two categories. Theoretical knowledge, which they valued immensely. And practical application, which they considered beneath educated men. Aristotle himself wrote that mechanical work was degrading to the human spirit. Philosophy, mathematics, rhetoric, these were noble pursuits. But building machines, improving manufacturing, making life easier for laborers? That was work for slaves. Drop your thoughts in the comments. Do you think this attitude still exists today? Because this cultural prejudice meant that brilliant engineers like Heron were seen as entertainers, not visionaries. His inventions delighted crowds at temples and theaters. But the idea of using them for industry? For replacing human effort with mechanical power? That would mean treating slave work as worthy of intellectual investment. The social system could not accommodate that cognitive leap. It was not a failure of engineering. It was a failure of imagination constrained by cultural assumptions. So here is what actually happened. And this is the moment everything finally makes sense. The Roman Empire eventually fell. The institutions that preserved knowledge, libraries, academies, engineering traditions, collapsed with it. But Heron's writings survived. They traveled east to the Islamic Golden Age, where scholars translated them into Arabic. And in the House of Wisdom in Baghdad, around 800 AD, engineers read Heron's work and began experimenting. The Banu Musa brothers built automata directly inspired by his designs. Al-Jazari created programmable machines that advanced mechanical engineering by centuries.